In the world of machine learning, models are not static entities. They require continuous updates and improvements to maintain their accuracy and relevance. This process is known as model retraining. Retraining is essential because the data landscape is constantly evolving, and models must adapt to new patterns and trends. Without retraining, a model's performance can degrade over time, leading to inaccurate predictions and suboptimal decisions. This presentation will delve into the concept of event-based retraining triggers, a crucial aspect of maintaining model efficacy. Event-based retraining triggers are specific conditions or events that signal the need for a model to be retrained. Unlike time-based triggers, which rely on a fixed schedule, event-based triggers are dynamic and responsive to changes in the data or environment. These triggers ensure that the model remains up-to-date and accurate by initiating retraining only when necessary. This approach can be more efficient and effective, as it focuses on actual changes that impact model performance rather than arbitrary time intervals. Event-based triggers are vital for maintaining the accuracy and reliability of machine learning models. They help in identifying the precise moments when a model's performance may be degrading due to changes in the data distribution, emerging trends, or shifts in user behavior. By responding to these events, organizations can ensure that their models remain relevant and continue to provide accurate predictions. This proactive approach minimizes the risk of model obsolescence and enhances the overall decision-making process. There are several types of event-based triggers that can signal the need for model retraining. These include data drift, concept drift, performance degradation, and external events. Data drift occurs when the statistical properties of the input data change over time. Concept drift refers to changes in the relationship between input data and the target variable. Performance degradation is observed when the model's accuracy or other performance metrics decline. External events, such as regulatory changes or market shifts, can also necessitate retraining. Data drift detection involves monitoring the statistical properties of the input data to identify significant changes. Techniques such as Population Stability Index, PSI, Kolmogorov-Smirnov KS test, and chi-square test can be used to detect data drift. When data drift is detected, it indicates that the model may no longer be performing optimally, and retraining may be required. By continuously monitoring data drift, organizations can ensure that their models remain aligned with the current data distribution. Concept drift detection focuses on changes in the relationship between input features and the target variable. This can be more challenging to detect than data drift, as it requires monitoring the model's performance over time. Techniques such as sliding window analysis, hypothesis testing, and ensemble methods can be used to identify concept drift. When concept drift is detected, it suggests that the underlying patterns in the data have changed, and the model needs to be retrained to capture these new patterns. Performance degradation is a clear indicator that a model may need retraining. This involves tracking key performance metrics such as accuracy, precision, recall, and F1 score. When these metrics fall below a predefined threshold, it signals that the model's predictions are no longer reliable. Regularly monitoring performance metrics allows organizations to detect degradation early and initiate retraining before the model's performance significantly impacts business outcomes. External events, such as regulatory changes, market shifts, or significant societal events, can impact the relevance and accuracy of a model. For example, a new law may change the way data is collected or processed, requiring the model to be retrained to comply with the new regulations. Similarly, a sudden market shift may alter consumer behavior, necessitating model updates. By staying attuned to external events, organizations can proactively retrain their models to adapt to new conditions and maintain their effectiveness. Implementing event-based retraining triggers involves setting up monitoring systems to detect relevant events and automate the retraining process. This can be achieved through a combination of data pipelines, monitoring tools, and automated workflows. For instance, data drift detection can be integrated into the data pipeline, triggering an alert when significant changes are detected. Automated workflows can then initiate the retraining process, ensuring that the model is updated promptly and efficiently. While event-based retraining triggers offer numerous benefits, they also come with challenges. One of the main challenges is accurately detecting relevant events without generating false positives. Additionally, the retraining process itself can be resource intensive, requiring careful management of computational resources and data. Organizations must also consider the potential impact of frequent retraining on model stability and performance. Balancing these factors is crucial for the successful implementation of event-based retraining triggers. Consider a retail company using a machine learning model to forecast product demand. The company implements event-based retraining triggers to maintain the model's accuracy. They monitor data drift by tracking changes in sales data distribution and detect concept drift by analyzing the relationship between promotional activities and sales. Performance metrics such as forecast accuracy are continuously monitored. When significant changes are detected, the model is retrained to incorporate the latest data and trends, ensuring accurate demand forecasts and optimal inventory management. To effectively implement event-based retraining triggers, organizations should follow best practices such as defining clear thresholds for detecting events, using robust monitoring tools, and automating the retraining process. Regularly reviewing and updating the criteria for event detection ensures that the triggers remain relevant. Additionally, maintaining comprehensive documentation of the retraining process and its outcomes helps in understanding the impact of retraining and making informed decisions. By adhering to these best practices, organizations can maximize the benefits of event-based retraining triggers. The field of model retraining is continuously evolving, with new techniques and technologies emerging to enhance the process. Future trends may include the use of advanced machine learning algorithms for more accurate event detection, increased automation of the retraining process, and the integration of real-time data streams for immediate retraining. Additionally, the development of more sophisticated monitoring tools and frameworks will enable organizations to implement event-based retraining triggers more effectively. Staying abreast of these trends will be crucial for organizations looking to maintain the accuracy and relevance of their machine learning models. Event-based retraining triggers are a powerful tool for maintaining the accuracy and relevance of machine learning models. By responding to specific events that impact model performance, organizations can ensure that their models remain up-to-date and reliable. Key takeaways include understanding the importance of event-based triggers, the types of events that can signal the need for retraining, and best practices for implementing these triggers. By adopting a proactive approach to model retraining, organizations can enhance their decision-making processes and achieve better outcomes.